So on the web, I pulled off a typical unconventional battery. It should look fairly familiar to batteries that your company may have. And my question to you to start off with is, do you see that there's a major process safety error in the design? And I'm not asking you to respond. We'll have question and answers afterwards. But just have a look. What's wrong with this? Well, let me guide you through a little bit on what we're looking at. You have a hot section of the plant. You have the heater treater and some separators up there. All the piping is at grade. The tanks are located, I don't know, probably 100 feet away from the direct fired equipment. And I'm pretty sure these are the flare knockouts. And the lines to the flare are pocketed here and here. And so what's the big deal? I mean, it's almost right. Unconventional, you have to build the facilities as cheap as possible, and laying them at grade is a cheap way of doing it. But what happens if water accumulates in there, and this happens to be in West Texas or North Dakota, and the water freezes? Then the flare is completely blocked. And with relief systems, you're supposed to have a clear and open path to the flare. You want to keep it as simple as possible. It's your last resort. And when the relief valves go off, if that's blocked, then you'll have loss of containment. You'll have potentially loss of the asset and loss of life. If it's not blocked, it's going to continue to accumulate liquids every time it's used. And this is what could happen. Yeah, it's not the worst thing in the world, but it's not operating right. And then if you want to get really dramatic, this one was about 6,000 barrels a day up in North Dakota. They filled it's a 300-foot tall stack, a meter in diameter, and they filled it all the way to the top and put out about 5,000 or 6,000 barrels. So the next thing I wanted you to look at is what are these things? This is after a fire at a PEMEX refinery. What you're looking at, that's all that's left of the operator. Those are the steel toes of his boots. And you can read this later. This just talks about the incident. But you've got to remember, we want to operate safely. We don't want to hurt anybody. We want everybody to come home safe. And copies of this presentation are in Dropbox. One of the things I'm going to be talking about is how I almost died 20 years ago offshore. It's going to be my safety moment, but I was looking at some slides in July 6th of '88, so it's a 30-year anniversary of Piper Alpha that's coming up. If you're not familiar with the incident, please take some time to go to Wikipedia and just read about it. And it's about simultaneous operations, management of change, whether the job was completed, and whether the equipment was ready to run. And people made assumptions, and it's one of the worst, if not the worst, offshore accident in terms of loss of life. The other reason I mentioned Piper is this is the preamble to the report that was done afterwards from Appleton. Safety is not an intellectual exercise to keep us in work. It's a matter of life and death. It's the sum of our contributions to safety management that determines whether the people we work with live or die, and on Piper they died. The reason I mention this is we do a lot of work. If you've ever been to a HAZOP, they're grueling, they're boring, it's an agonizing detail, but it's the only time it's going to be looked at, guys. So do the best job you can, because you never know how many accidents you're going to avoid or how many lives you'll save going forward. It's real important. This is what my expectation is for you guys. I want to provide you with solutions and share some best practices and show you through my eyes what I see when I look at an unconventional battery. and make you a more effective engineer at work, as well as show you some of the tools and how I use them for example, on root cause failure analysis, and how I apply some of these tools. Also, how I apply some of the learnings you get from the Campbell G4 gas courses with phase envelopes and whatnot. I'm not going to spend a lot of time explaining those tools. I'm going to show them to you and show them how you can get to great solutions. But after this presentation, we're going to spend about an hour together. You'll be able to apply them today and not tomorrow and make your company more money and be safer. So this is my standard disclaimer. While all of my stories are true and related in a technically correct manner, I've often forgotten where they occurred. I've been around, I'm old. Thus, references to specific companies and location are meaningless and should be regarded as pure fiction. So this is a preview of an August tip of the month that's going to come out. And it was actually broken down. It's already being edited, but it's going to be broken into 3. So the first one's on stabilization, the next one will be on process safety, and then it'll come out in November, and then the final one will come out next year on the economics for unconventionals. So what's in it for you in this presentation is solutions that will reduce downtime, increase revenue, and safeguard your people and your assets. So are you having vapor pressure issues in the winter? One operator I heard from the president had 100,000 barrels a day shut in for over a month last year. Are your tanks venting gas? Are you having problems meeting quad 0? And then are you getting oxygen into the feed of your gas plant from your vapor recovery systems? Even if you don't own the gas plant, this causes major corrosion issues in plants and can destroy the hot section of the stripper in a matter of months. And it also destroys the solution, so the treating capability is not there. It's a big issue if you get oxygen into your system. Also, do you have infinite recycling? Are you sending your vapor recovery compressor suction and discharge liquids back to the stock tanks? There's a tip of the month that I wrote on that last year that's also in the link. But if you're experiencing any of these issues, your surface facilities are working as designed, and the problem is the design. So Kendra gave me a nice introduction. We'll have some of the Pole Everywhere polls. I'll talk about how I almost got killed offshore 20 years ago. And the only reason I'm here to tell the tale is we broke for lunch and there wasn't an ignition source. Otherwise it would have been really bad, and I'll show you why. Then we'll talk about this tip of the month for meeting vapor pressure, go through a root cause analysis on treater burner failures, and provide some answers and solutions that are proven. And then under tips, I've got copies of the presentations, some tools, and some files, copies of the Unease models that I'm going to be showing, as well as PDF printouts of the reports from Unease. So if you don't have the software, you can still peruse the files if you're interested. And then I've included copies of all the videos I'm showing, as well as some videos for some other software that you can take a look and learn more about. And then after that, we'll have a discussion. So I've got about 40 years of experience. Okay, so how I almost died 20 years ago. Kind of an important, near and dear thing to my heart. I kind of like this picture of Mark Twain too, because he looks like he's got something to say. And this quote is, it's not what you don't know that gets you in trouble or almost kills you. It's what you know for sure that just ain't so. And I've seen this a lot on accident investigations. What you think is for certain that you could stake your life on, literally, it's just not right. It ain't so. So this is Garden Banks 128, the Enchilada platform, and we were conducting simultaneous operations. We had drilling. Operations was commissioning, bringing on some wells, and the platform at the time was also boosting oil and natural gas from the auger platform, so it was going up and over the platform. And I was doing some construction work to tie in the salsa platform with the risers and the pig receivers that are on Enchilada. So one of the things that we were doing was cold cutting. So it shows a hydraulic device. It's non-sparking. It's like a big can opener. And if you're in an operating environment, you can use it to safely cut into pipe. So it's a real simple project that we were doing. We're cold cutting into this 8-inch gas line. We had it isolated. So what we did is put dry ice and then a plumber's plug, which is just a balloon with a vent, and we're isolated. And then the welder would tack on and weld the flange. And then after that, you can add a spool that's you already have pre-made and make the rest of the connections to tie the system together. So it's hot work, so you need a written work permit. And some of these things are the same things that happened 10 years earlier on Piper, and the lessons weren't learned. That's why after 30 years of Piper and after this presentation, learn from the mistakes that I have made and others have made going forward. So you got to conduct a JSA and a work permit, have gas detection, fire protection, a fire watch. So we had a safe work plan with the scope, the location, the hazards, the mitigation, and the recovery. We had approvals from management in New Orleans, the local management, contract foreman, the foreman on the platform, the PIC, person in charge for the drilling rig. And I thought it was great. We also had the people doing the work sign the work plan so that, you know, they knew what the hazards were with what we're getting ready to do. By the way, just as a side note, I hate SIMOPS. And we do it as a matter of course now. Growing up, it's a change that's happened with cost pressures. If you can avoid doing it, don't do it. So anyway, this is just a section that was in the safe work plan. All hot work shall be shut down if an unsafe condition is seen. All hydrocarbon lines will be isolated via lockout, tagout, and skilleted, blinded. All electrical sources will be disconnected. Copies of the plan will be in drawings. We had drawings. Be posted in the galley. Tarps to prevent contact of sparks on ignition sources, filling the drip pans with water, and shutting down some nearby equipment if there was a problem. We had morning meetings at 6 in the morning, and we even had the construction inspector sleeping with the ops foreman in the quarters, so there'd be really good communication. Now, one of the problems with SIMOPS is my work is controlled. I know what I'm doing. I have no idea what drilling is doing. I have no idea what operations is doing. Drilling may have a plan. I'm relying on them not to hurt me or my crew when I'm working. Operations work isn't planned and detailed like this, but I have no idea what they're doing around me. I'm relying on them to keep my crew safe. So we're working on the sub-cellar deck, and you can see the pig receivers. And that's what we're going to do, right? And we broke for lunch, came back. The welder was just putting his hood down, getting ready to strike an arc, and bam! There's high pressure gas. The plumber's plug, the stopple, flooding the deck with natural gas, high pressure natural gas. I'm looking at something that can't possibly be like Mark Twain. I'm isolated. What's going on? Well, Ops' work wasn't controlled. They made a connection into our system and jumped high pressure natural gas across our blinds by mistake. It was the longest minute to 30 seconds of my life. And again, the reason I'm here is it didn't find an ignition source. But how bad could it have been? Well, we had 100 people on board at the time. The gas jet was directed towards the escape capsule in the quarters. And we had wells and high volumes of oil and natural gas coming in from Auger. which is also what happened at Piper. They were processing gas from other platforms. So that's Bombay High off of India. Thank God it didn't happen. So what mistake did I make? SIMOP should have been halted during construction. The platform should have been shut down during construction, or danger do not operate tags should have been used. No, and that's exactly right. We should have used LOTO. LOTO was called out for in the plan, and I'm probably sure that they still say this. There's a real strong culture in the Gulf of Mexico, and they're real proud. And the saying is either that's not the way we do it in the Gulf, or this is the way that we do it in the Gulf. And for isolation, they didn't use proper danger do not operate LOTO tags when they're doing construction. So that would have provide an extra level of Swiss cheese in the Swiss cheese model, an independent layer of protection. It still's not going to stop the operator from tearing the tag off and doing what he's doing, but it'll give him a second, give us one more chance to stop him before it happens. If you go to Long Beach Harbor, there's a couple of shell platforms there, Ellen and Ellie. And when you get off the helideck, it says, this is not the Gulf of Mexico. So anyway, learn from this mistake. So I encourage you to think. Don't rely on policies, procedures, and permits. Always look for what the hazard is, what the barriers are, what could go wrong, and then how do you recover. And then a question I have for you is, I feel safe when I'm working in my onshore or offshore facility. Okay, that's great. We've got about 21 people who are logged on, and let me just show you the results. And 91% of you feel safe, 9% of you don't. And there's another paper that I'll show you that won't talk about. Don't forget to be afraid. Have a chronic sense of unease. Don't ever be comfortable, because then you get complacent. And the nearest analogy I can give for that is if you do any woodworking with a table saw, when you first start using it, you're scared to death and you're very safe planning what you're doing. Most people get hurt after they've used it for a long time and are just very complacent about the danger. The danger's there the whole time. Or even imagine when you first started driving a car, what the difference is when you get behind the wheel versus just riding along. And then now you can text and listen to the radio and eat and not really pay attention. So again, have a chronic sense of unease.